Rice has an amazing engineering school, and the neuroengineering program is world-renowned. Likewise, Houston Methodist has nationally and internationally recognized clinical programs in neurology and neurosurgery. Putting those together enables us to really solve the puzzle of how to bring neural function back to patients who've been injured or impaired due to disease.
We used to believe we couldn't repair the brain, but now we understand that we can harness the brain's own power using different modalities to get the brain to repair itself. So the whole overarching theme of the Center for Neural Systems Restoration is to incorporate multiple techniques, including neuromodulation, neurostimulation, to improve neural recovery of the brain and the spinal cord.
We believe this is a unique place in which you can not only have engineers, neuroscientists, and neurosurgeons working with each other, but we can have novel solutions to solve all diseases of the nervous system and to make an impact, right, that is lasting in the field.
I think that the center will be able to really translate both basic science activities and preclinical research and move it towards translational applications in people. And so having an environment where we can take the basic science at either Rice or here at Houston Methodist and bring it forward in a translational way to people, that's the strength of the center I see.
We work with people with severe neurological conditions. Our research really targets these questions. How can we not only improve person's quality of life or any function, but also how can we cause certain positive processes in the central nervous system leading to improvement in neural system.
So for instance, in Parkinson's, how do we make their disease more tolerable? How do we set the symptoms back several years? By using deep brain stimulation as an example, it allows us to put electrodes to a key part of the brain involved in a patient's symptoms. By stimulating, we can turn off their symptoms in some respect. We can delay their symptoms from progressing. How does it work? We still don't understand. We're developing an answer to that here at our program.
What makes our work unique here is that we are also targeting different functions, such as upper limb function and lower limb functions, and we apply both invasive and non-invasive technologies. One of our projects is improvement of upper limb function in people with tetraplegia due to spinal cord injury.
I was injured on March 11th, 2020, and that's when I fell on the side of my neck and I broke my neck. So after that, I wasn't really able to move much of my hands. It was hard. From there, I just kept doing rehab and got a couple surgeries to help try to get me back to where I want to be. Now I'm able to pick things up or get outside the house and get around with school, hang out with friends, and be able to do things like, I guess you could say, normally again. So just working with everybody, it's always been very smooth, very helpful, and it's definitely a place where it feels like you can improve, and it's changed my life and made my life better day to day, every day. So it's been amazing.
Unfortunately, there's so many neurological disorders, but as you can imagine, many patients do not respond to pharmaceutical solutions. And that's where neurosurgeons and people like us, engineers, get involved. Try to see what we can do to mitigate the disorders using technology. One project that we're working on is a non-invasive technology that patients could put on as a cap and measure the lymphatic flow. And if the flow is low, then we can add other modalities like CAP to modulate the brain and hopefully help the patients mitigate the early onset of Alzheimer's.
We also design robotic devices and exoskeletons that can be used for physically interacting with people. In particular, we design these exoskeletons for the upper limb that can deliver rehabilitation therapy for individuals with stroke and spinal cord injury. Through the center now, my students and postdocs have regular engagement and interaction with the researchers and clinicians and physical therapists at Houston Methodist to test out our robotic devices and control algorithms to see how they'll perform with that patient population and get that immediate feedback about the utility of the devices and the controllers and how it might impact patient care.
We're going to encourage students from Rice and all over the country and all over the world to join us in this endeavor as we develop the center and cures for the brain and spinal cord.
And that is such a unique opportunity to have as a very early career grad student in this field. Just listening to all of these experts, everybody is so impassioned about the work that they're doing. I can really only imagine how many more students are going to be able to work with the clinicians. We're all trying to develop these technologies to diagnose and treat neurological disorders. It's a very exciting time to be there.
We have so many patients who need our help. This really drives the researchers' focus and motivates them to excel in their research and helps us to drive towards the ultimate goal of curing disease and restoring hope.
We are fortunate enough to develop a center and be in a time period where we have the technology, both biological as well as engineering, to make a difference in neural recovery.
We think the long-range impact of this collaborative center is going to be incredible. We're talking about solving problems that really weren't dreamed of even a few years ago.